Hello everyone, my name is Jared and welcome back to the Virtual R workshop series. This is the fourth workshop in the series and today we will be looking at data manipulation with Tidyverse. So let's check out our learning outcomes. So after this workshop, participants should be able to do the following: describe the concept of data wrangling, describe how Tibbles are different from data frames, explain how to convert wide or long data to tidy data, be familiar with key Dplyr verbs and use them to transform data, zoom in on data using the piping operator, and finally, compare subgroups with the GroupBy in conjunction with piping and Dplyr verbs. All right, so I want to talk a little bit about the data wrangling process. So the reason we need to perform data wrangling on data is because data is generally not usually given in the format that you would like. So when you're on a job, you'll never really get these perfectly clean data sets, so you will need to manipulate them in some way. So there are three steps to this data wrangling process. The first is importing, which we covered in a previous workshop. Up next is tidying and then transforming, which we will cover today. So the Tidyverse actually offers a lot of tools to help in this process. So the Tidyverse is a collection of packages created by Hadley Wickham, who actually works at RStudio. So this package is great for the data wrangling process. You can also see in the visualization below how the wrangling process fits in to the broader data analyst idea. So we have importing, tidying, and then transforming, which is all under the branch of data wrangling. So we will take a look at that today. If you want a little bit more resources for data wrangling, Hadley Wickham actually wrote a great book that is available for free online. It's called R for Data Science. The link should be in the chat for you right now. And this is a great book if you want to get a little bit more practice in. It has exercises and everything along those lines. All right, so let's jump into our studio. So we can open that up. We'll do our standard process of creating a project. So we'll go to File, New Project. We won't save. Oh, that's all right. We will click New Directory and then New Project. I'm just going to create it on my desktop and I'll name it our Workshop 4. So let's create this project. All right, we should now have a .r project file in the lower right-hand corner. So let's make our script. We can go to File, New File, and then our script. And I like to type something before I save it. And I'm just going to call it our Workshop 4 script. You can name it whatever you would like. All right. Now you should have a .r project file and a .r script file. All right, so I mentioned the Tidyverse before, so we will be using that throughout today's workshop. So if you don't already have it installed, we can run this command to install it. So it's going to be install .packages, and then you just need to pass in the name Tidyverse. And then you can just run this line by hitting Control and Enter at the same time. I'm not going to run it as I already have it installed and it takes a minute or two to fully install. So after you install it, or if you already have it installed, we need to run the library command and pass in Tidyverse so that we can load the package, or in this case, set of packages. So we can run this. it will take a second and we should get some feedback in the console. And then we should be ready to go. So while this is installing on your machines, I want to talk about Tibbles. So what Tibbles are a new or a more advanced version of data frames. The Tidyverse uses Tibbles for all of its packages, so we kind of need to be aware of them. So there are some differences between Tibbles and data frames. So Tibbles are a bit more modern and they kind of cut out old unused features of data frames. They actually will never change the input type when you are creating them, so your data type will not be changed. Columns can actually be lists in Tibbles, and Tibbles can also have non-standard column names, meaning that there can be spaces in the column name and it can start with numbers as well. But what I want to look at here are the two main changes that you will notice when actually working with Tibbles. So let's create our Tibble first. So I'm going to create a Tibble cars.tib, that would be my name. And then to create a Tibble, we will use the as_Tibble command. And then we just need to pass in our data. In our case, we're just going to use the built-in empty cars data. So we can run this line by hitting Control and Enter at the same time. And we now have a cars.tib piece of data. So we can hover over it and notice its data type is now a TBL_df. So that means it's just a Tibble. So you can pass in data frames and this as_Tibble command will output a Tibble for you. If we want to instead convert from a Tibble to a data frame, we can do that. So I'm going to name this cars.df for data frame. And instead of as_Tibble, I'm going to run as.data.frame. And then we can pass in our Tibble. So our cars Tibble, and we can run that. And now if I hover over the cars.df, it will show as a data frame. So this is great if you are working with legacy code that expects data frames. You can use the as_DataFrames command. And if you're using Tidyverse or something that expects Tibbles, you can use the as_Tibbles command. All right, so everybody should have the Tidyverse hopefully installed and up and running by now. So let's show the differences when working with Tibbles. So the first difference is going to be in regards to printing. So if I were to print this Tibble by running the print command, it will actually only show us the first 10 rows and will show us the data types for each of the columns. So this is great. This is much neater than printing a data frame. Printing a data frame will print as many as it can fit in the console, and that can really be overwhelming when you're just trying to get an idea of the data you're working with. You can actually pass in some parameters such as n equals. So in this case, if I put 15, it would print 15 rows. And if you want to see all of the columns, you can set width to INF, which is infinity, and it will print out all of the columns. Otherwise, it will just print out a smaller selection because sometimes in your data, you can have hundreds of columns, really. All right, the next main difference is going to be with subsetting. So usually when subsetting a data frame with brackets, so if I want the first column, if I run this, you will actually notice that the output is another Tibble. So usually we would get a vector when we just run this single bracket, but when you're dealing with Tibbles, you will actually get another Tibble when you use the bracket or single brackets. If we want to get the vector, we actually need to use double brackets here, which we can now run. And this is our standard vector that we would get if we were accessing a column in a regular data frame. All right, so those are the two main working differences when dealing with Tibbles. Otherwise, they are very similar to data frames. All right, I want to now talk about tidy data. So let's jump back over to the presentation. All right, so tidy data is kind of a philosophy about data, and it has 3 rules. So each variable must have its own column. So if you see on the bottom left, each column is just one singular variable, so country or year. The second rule is that each observation must have its own row, so that will be in the middle there. So each observation has all of its data in only one singular row. And finally, each value must actually have its own cell. So if I were to pick any random cell in a set of tidy data, it should contain just one singular value. You may ask, why do we want data in this tidy format? It's because it is so we can apply statistics to it and also data visualization. So statistics and data visualization will expect data in this format. All right, so we can jump back over to RStudio and start to deal with some different types of untidy data and how to get them into a tidy data format. So I'm going to clear the data I have already, and we can clear the console, and we can get going. So first off, we need to get some data that is not tidy. So this command should be in the chat right now, and then you can run this, and you should access the data that is stored on my GitHub and easily import it into RStudio. All right, and we can actually take a look at this data set, and let's see if it is actually tidy data or not. So the state column only holds states, which is great. But if you see, each column after that is actually a year. So in order for this to be tidy, we actually need all of the years to just be in one column, and then all of the population data to just be in one column. So right now, this data set is in a wide format. So we need to kind of squish it and make it in a longer format so that it can be tidy. So the way we will do that is by running the pivot longer function, and it's going to ask for some parameters. So it's going to first ask for the data. So that's going to be our wide population data. Up next, it's going to ask for all of the columns that are of the same variable. So the variable will be year in this case. So we will pass in the 3 columns that contain the year. So that's 2018, 2019, and 2020. So we need to pass these in. So 2018, 2019, and 2020. All right, up next is going to be a names to parameter, and that is just essentially asking what does this mean? What are these years? So we can say that they are the years, or the variable is the year. And then finally, we need to pass a values to command or parameter. And that is essentially saying, what are these numbers? So this is actually population data. So those numbers mean population. All right, so let's actually store that output somewhere. We can store it in a tidy population variable. So let's run this. And notice the tidy population actually has 153 observations of 3 variables. So we can open it up. And now state has its own column, years have their own column, and the population has its own column. So each variable in this data set has its own column. So we are doing well, and we now have a tidy data set. And we can also check that each row only contains its own data, which it does. So great, we just converted a wide data set into a tidy data set. We can do the same with long data sets. So if you could grab this link from the chat, it's going to be called long states. And then we will just read in another data set from my GitHub. So if we run this, we can take a look at it. And when you look at this, we can kind of check if it is already tidy data. State looks all right because it's only the state variable, but condition is actually holding 3 variables within that column. So it's holding the population, employment rate, and number of colleges variables. So that is not tidy data because we have 3 variables in one column. So we need to deal with that. So since that is long data, we kind of need to squish it down and make it a little bit wider. So we will use the pivot wider command and now pass in some parameters. So it's going to ask for the data first. So we will give it long states. And secondly, it's going to ask for the names from. So this is essentially asking what column are the variable names in. And in our case, it's going to be the condition column. And lastly, it's going to ask you, where should I look for the values? So in our case, that column is called measure. So we can pass in measure. And let's store all of that in a tidy states variable. There we go. And we can run that. And now open it up and take a look at it. All right. So if we just briefly look over this, we can tell that each variable is in only one column. So population, employment rate, number of colleges is only in one column each. And each observation, or in this case state, has only one row, which is great. We now have a tidy data set. Also, these numbers are made up, so please don't use them for any real analysis. It's just going to be for demonstration. All right. So that's 2 types of or operations you can do to deal with some untidy data. Up next, I want to talk about separating and uniting data. So let's read in some data from my GitHub again. So this link should be in the chat for you. It should be state rate. I'm also going to clear all of my other pieces of data just so we don't get confused. So we can run this state rate read CSV command and take a look at it. Close out of all of this. All right. And we can kind of get an idea of this. So we have state, which is fine, but we also have a rate column. So what this rate is going to be the death rate for the state. So it's going to be number of deaths divided by total population. So this is definitely not tidy data because we actually have two pieces or two variables in one column. We have deaths and population. So we need to deal with that somehow. So the way we will deal with this is by using the separate function. So what the separate function will do is actually look through a whichever column we specify, and it will look for numbers and see if there's anything in between them. So look for like an odd out of place character. So in our case, it's going to be the slash, but it could be a comma or something along those lines. So let's actually run it. So it's going to ask for our data. It's going to be state rate. It is then going to ask which column we would like to separate or split up, which is going to be the rate column. And then finally, it's going to ask into which two columns or however many columns would we like to split the data up into. So since we have number of deaths divided by population, we will just give it two column names. So first is going to be deaths, and second will be population. We pick these two columns because that's what we know these pieces of information to be. All right, let's actually store this in a tidy rate variable, and then we can run it. And let's make this a little bigger. We can now look at the tidy rate data, and we now have a deaths column and a population column, which is great. So we have three variables with three columns, and each variable is only in its respective column, and each row is only one observation. So we successfully created tidy data from this. All right, we can also do the exact opposite of separating the two columns. We can actually unite the two columns. So it'll ask for our data again. So we can pass in tidy rate. It will then ask into which column we would like to unite them into. So we will just give it a rate name. That's going to ask which columns we would like to unite. That's just going to be deaths and population. Finally, it's going to ask for a separator. So it's going to ask which separator would you like to use. In this case, we can just use a slash. So let's put this in a variable called untidy rate. And then we can run this and look at our untidy rate data. And here we go. This looks identical to the original state rate, which is exactly what we wanted. So this is not tidy data, but we did successfully unite those two columns into one. All right. So we can now talk a little bit about dealing with missing data. So missing data is another common issue that can happen when you are dealing with data sets. So let me clear all of my data. So in this case, we will just use the built-in data set for this, which is going to be called air quality. And I'm just storing it in an air quality variable. So we can run this. and we can take a little look at it. And if we just briefly glance through it, we notice there are some NA values. So NA in R means that there is not a value there. So the value is missing, which is not going to be good for any analysis or data visualization. So let's actually get a better idea of how many are missing. So we can run the summary command and pass in our data. So when we run this, we get a breakdown by columns. And at the bottom, you can actually see where it says NAs and then some amount of values. So in this first column, the ozone column, we are actually missing 37 different pieces of data. In the solar radiation column, we're missing 7. And in wind, temperature, and month, it looks like we're not missing any. So we actually need a way to deal with these missing values. There are quite a lot of ways to deal with them. You can just completely drop them, but in our case, we would have to drop 36 rows, or 36 observations, and that would really reduce the sample size of our data. So another way we can deal with missing values is called mean replacement. So what mean replacement means is that everywhere we see an NA value, we will actually replace it with the mean of the column. So in order to do this, we actually need to first calculate the mean of the column. So we can do that with ozone. So I'm going to call this variable ozone mean. And we can just run the mean function and pass in the column. So it's just going to be arq.df and the $sign operator, and we will go for the ozone column. So if I run this, you will actually see we get an error. It's called, or not an error, rather, we get a value that is NA real. So this means that there were some NA values in that column, and you can't really do math with NA values. So that is why we need to somehow deal with them. So we can actually pass in another parameter to mean, which is na.rm equals, and we can set this to true. So this will actually ignore or remove all of those NA values and then calculate the mean. So we can run this. And notice we now get a numerical value of 42 point something. So that's great. We now have our mean we can replace all of the NAs with. But now we need to access all of the NA values. So the way I'm going to do that is by typing in is.na, and then I'm going to access that ozone column. So if we were to run this, we should get a vector of Boolean values, or true or falses. So anywhere there is a true, that means there is a missing value. And what we can actually do is subset this with respect to the original column, and we should only get the missing values. So let's test this out. So let's access that original column again. So arq.df, and that column is ozone. And what we can do is put this entire command into brackets. And now if I run this, we should get a vector of all of the NA values in the column. From this, we can easily overwrite these values by using the assignment operator and replacing it with the ozone mean. So we can run this, And let's take a look at our air quality again. And you will notice there are all the missing values have been replaced by the mean value. So that's why it is called mean value replacement. And let's run that summary command again. You will see that the ozone column now has no missing values, which is great. We can perform some statistics on this and data visualization and move forward.
Jarrod, just letting you know I have 15 minutes.
Thank you. And you can repeat the process with the solar radiation column as well, but we won't do that here. All right. I would now like to talk about some data transformation with Dplyr. So Dplyr is a package under the Tidyverse branch, and it has a lot of useful functions, also known as verbs. So the functions in Dplyr are going to be known as verbs. So we can demonstrate that now. So let's clear the data, and I'll clear my console as well. And we can begin. So we need some data here. So I'm just going to create a cars variable and pass it the empty cars built-in dataset to R. So we can run this, and we can open it just to get a brief idea. But it is the standard empty cars dataset built into R. All right, so the first verb I'd like to talk about is going to be filter. So what filter allows you to easily do is just filter the data based on some commands or ideas you have. So in our case, let's say I just wanted to get to all of the cars that are V8 and automatic. So I can run the filter verb, pass in the original data, and then specify what my conditions are. So we can actually look at the data set, and we notice the CYL is number of cylinders. So we need to use the double equal sign operator because we want cylinders to be equal to 0. And we want AM, which is automatic transmission, to be equal to 0. So according to the empty cars documentation, AM, when it has a 0 value, means automatic transmission. So we can run this and look at our V8 auto output. And we can see all of the cylinders are 8, and all of the AM column, or the automatic transmission column, is 0, which is great. So those are our two conditions, and they were met correctly. All right, up next is going to be the arrange verb. This allows you to actually sort by increasing or decreasing values on whichever condition or whatever column you have. So we will type in arrange here, pass in our data, which is just going to be cars, and then the column we want to sort on. So in this case, it'll be MPG, and we can look at our output in the console below. And you can see it is in ascending order, so it will give us our lowest MPG first, and then increase from there. So that's a nice way to arrange your data. You can also run or pass in the column to this descending function, or DESC. And now when I run this, you will notice that the output starts at the highest value and is in descending order based on that MPG column, which is great. All right, up next is going to be the select verb. We will run that by just typing in select and passing in our data. Select allows us to easily select which columns we want out of a data set. So in our case, let's just grab 4 columns. So how about we grab MPG, number of cylinders, how much horsepower the car makes, and its weight. So we can run this. And if you see in our output below, we only get those 4 columns that we care about. This is great when you are dealing with large data sets with possibly 100 columns. You may only want to grab the data that is relevant to your analysis at the time. All right, up next is going to be the mutate verb. We will run that by just typing in mutate and then passing in our car's data. What mutate will do is actually create a column based on whatever math you would like to do. So in our case, let's say I want to create a power to weight ratio. So the way we would calculate power to weight is just going to be how much power the car makes divided by its weight. So these are 2 other columns in our data set. And it will then create a column called power to weight based off of this formula. So we can run this, scroll back up, and notice it is now a power to weight column, and we have some data here. So that's a great and easy way to quickly add another column based off of 2 or more other columns. So you can pass in whatever math function you would like here. All right, up next is going to be the summarize function. So we will again pass in our data, and we can actually create, again, another type of summary. So let's say I want to calculate the average MPG for all of the cars. So the way we calculate average MPG is just going to be mean, and we'll just pass in the MPG column. So let's run that. And if you notice, summarize the function, when you pass it in an entire data set, it's not very helpful. We could have easily calculated the average MPG for all of the cars before. So this alone isn't that helpful, but it can be made much more helpful in conjunction with the GroupBy function. So we will run this GroupBy function. We need to pass in the data again, and we need to tell it which or what column to group by. So we will run the cylinder, or we will pass it the cylinder column, because I want to eventually be able to calculate average MPG based on number of cylinders. So I'm going to create a variable called by cylinder, and we can run this. And there we go. If we look at the data set, not much has really changed. But when we again run that summarize function and instead pass in the by cylinder data, and again calculate average MPG, which is just calculated by finding the mean of MPG, we can run this, and notice we have now created a summary based on a number of cylinders for each car. So all of the 4-cylinder cars get on average 26.7 MPG, and so on. So this is a great way to quickly analyze your data based on a grouping of conditions. So we wanted cylinders in that case. All right, so up next, I want to talk about the piping operator. So when you have or are importing or dealing with data, you might want to do a combination of all of these different verbs. And it can get pretty messy if you just run one at a time. So this is where the pipe operator comes in handy. So I will demonstrate that. So you first type in the data you would like to deal with, and then use this piping operator, which is %, then greater than, and then % again. Then when you press enter, it should give you a little space here. So what the piping operator does is kind of create a pipe for you to push all of your data through. And as your data goes through this pipe, a lot of different verbs and actions are happening to your data. All right, so let's demonstrate this with a kind of more real world example. So let's say I am shopping for a car, and I really only care about four main parameters about my car. So I only care about MPG, number of cylinders, horsepower, and weight. So let's just select those columns. So we will run the select verb, and we will just type in the columns we want. So MPG, CYL, horsepower, and weight. Notice with the piping operator, we don't need to pass in the data like we did up here, because we already told it which data to deal with previously. All right, so if I run this command, you will notice it is actually identical to when we ran this select command up here. So single pipes aren't the most useful, but when you start to chain them, that's when they become great. We're shopping for a car. I only care about those four columns. So let's add another step to this pipe by again using the piping operator. We can press enter. And let's say I care about the performance of the car. So I care about the power to weight ratio. So let's say I want a car with a high power of weight ratio. So we first need to calculate that. So we can run the mutate verb and tell it what we want. So I want to calculate power to weight. So I'll just give it the name power to weight. And that is calculated by doing horsepower divided by weight of each car. And now when I run this, we can look at our data, and we now have a power to weight column, just like we did previously. But first this select command was ran, and then the mutate command was ran. So it's traveling along through that pipe and having a lot of operations done on it. All right, so let's add one more step to this pipe. So we've gotten our all the things I really care about. I care about MPG cylinders and its power to weight ratio. So let's actually use the filter verb to meet my conditions. So let's say I need a car that is going to get better than 18 miles per gallon. So I will just give this filter command the condition that MPG needs to be greater than 18. And I kind of care about how fun my car is to drive, and power to weight ratio is a metric to observe that. So I want my power to weight ratio to be greater than, how about 40? So it should be a little bit fun. So we can now run this, and we have now reduced our large data of 32 observations into only 7 cars. So if you were actually shopping for a car, 7 choices is much more manageable than 32. So this is just one example of the piping operator. So again, to go over it, the cars data is first piped through this select command. It then travels through the mutate command, and then finally it will travel through this filter command. And this is great. It's a very nice and simple way to deal with a lot of steps on data. I do want to demonstrate what it would look like if we didn't have that piping operator. So I'm just
Jarrod, just keep in mind you have about 5 minutes left.
All right, great. So this is, we can actually run this and look at it. And well, oops, I changed that. So if we run all of these 3 lines of code, we will actually get the same output as we did before with the piping operator, or the piping function. So if you look at this, it's actually much more difficult to understand and get an idea for than the piping operator. At first, I was slightly overwhelmed with the piping operator, but as I got to use it, it is, in my opinion, much more simple to understand than having to deal with something like this. Because here we need to be conscious of what data we're passing in and making sure we're not overwriting any original data. And it is just a little bit uglier to look at than this nice, clean piping operator. All right, so that actually concludes the programming aspect. So we can jump back to our learning outcomes and go over those. Hopefully. All right, so after taking this workshop, participants should be able to do the following. Describe the concept of data wrangling, describe how Tibbles are different from data frames, explain how to convert wide or long data into tidy data, be familiar with the key Dplyr verbs and use them to transform the data, zoom in on the data using the piping operator, and finally compare subgroups with GroupBy in conjunction with piping and Dplyr verbs. All right. Thank you all very much. Please feel free to connect with me on LinkedIn if you haven't done so already, and follow all of the social media for the club and center. Thank you.